So in this video, we're going to look at question 2 in the packet. For question 2, you need to know some basic terminology that we're going to use. So capital B stands for the area of the base. So if the base is a rectangle, then you use the area formula for rectangle, which is length times width. If the base is a triangle, use the area formula for a triangle, which is 1/2 base times height. So just keep that in mind. H for cylinders and cones is always the distance between the two bases. So again, if my figure's turned, it where the bases are not like on the bottom at the top, but instead of left or right, the distance is going to be that like horizontal distance between those two bases. If my pyramid is sitting up with the base being like on the floor and at the top, then the height is that vertical distance between them. The height for a cone or a pyramid is the distance between the vertex and the base. So again, we kind of talked about it in these pictures, like this is the height for a prism. Here's my height for my cylinder. Again, it could be turned. So it's either this horizontal distance or this vertical. And then for a cone and pyramid, it's from the vertex to the middle of the base is the height. L is that slant height. That's that height when you have like a cone. It's on this side is that slant height, and we use the letter lowercase l, either cursive or like this. Capital L is the length of the base, and capital W is the width of the base. So just keep those all in mind when we're doing these. Sometimes instead of L for slant height, sometimes they use S for slant height as well. Okay, it just depends again on the textbook that you use, so just be aware of that. The reason is because we're going to use like L also for length, so it can be confusing. Okay, so we're going to look and fill out these formulas. I highly recommend like just stopping and thinking about how you would find the surface area and volume, or at least the surface area for each of these. So for a rectangular prism, again, what we would do is we would find the area of all of these faces and add them together. And so how the surface area for a rectangular prism works is we have this is my height. We're going to call this my width and this my length. And what we would do is we would find the area of this base here of this bottom, which would be width times length. And that's the same. I have one on top that's the same. So it'd be like 2 width times length. And then we would add the area of the other faces. So this front face and the back face would be the width times the height. And I have 2 of those. So it's 2 width times height. And then my right side is the height times the length. And my left side is also the height times length if I'm finding this rectangle. And so I have 2 height times width. And so this is the formula. Now the order you have it in really doesn't matter. But it just matters that you're multiplying like 2 times width times length, and then 2 times width times height, and then 2 times height times width. Now for volume, whenever we find the volume of any pyramid or cylinder, what we're doing is we find volume is always like the area of the base times the height of the pyramid. That's how volume works. So the volume for rectangular prism is the area of the base, which is the width times the length, and we would multiply by the height. So it's length times width times height. And you can use capital H or lowercase, they're kind of interchangeable. I labeled it lowercase, so I'll do that on my formula. Okay, so that's the volume. Now for a cube, you can use these same formulas, but just kind of a shortcut is all the sides are S, like they're all the same. So these are all the like for the surface area, they would all be the same, like 2 S times S plus 2S times S plus 2S times S. So if I were to simplify that, I would have like 2S squared plus 2S squared plus 2S squared. And since they're all like terms, I can add them and I get 2 plus 2 plus 2. So I get 6S squared. And that is the formula for a cube, kind of the shortcut. And if you're working backwards, it's much easier if you know this formula. The volume is the same idea. These are the same, the length, width, and height. So it's S times S times S. So it's S cubed is the volume of a cube. Okay, so a triangular prism is a little bit trickier. So we'll do the volume in it. For the volume, we would find the area of this base, which I'm going to call big B, and I'd multiply it by the height, which is the distance between the two bases. Or here, this is my big B, this is my height. So the volume we write as capital B times H. Now, for capital B, we calculate the area of one of these triangles, one of the bases, which is 1/2 base times height. And then this is the most confusing thing about this. Capital B, again, stands for the area of the base. The lowercase b is the base of the triangle. So it's one of these sides. And then the height of that triangle, I'm going to write HT for triangle, is the height here of this triangle. And so I'm finding the area of this triangle. And I'm saying this is a right triangle, so that's why I'm doing it this way. This is my height of my triangle. This is the base of my triangle. So that. And we're doing 1/2 the height of the triangle times the base of the triangle to get big B for a triangular prism. Okay. For the surface area of a triangular prism, what we're doing is we would find the area of each of these triangles and add them together. So we write it as 2 times big B. And then we add plus the lateral area, which is the area of all the rectangles on the side, which is the height times the perimeter again. And so again, the tricky thing is for a triangle, for big B, you're doing 1/2 the base of the triangle times the height of the triangle. And this height is different than the height of the prism. So you have to remember that. Okay. A cylinder is a little bit more straightforward. So the surface area of a cylinder is the area of these two circles, which would be pi r squared. And since there's 2 of them, we'd multiply by 2. So it's 2 pi r squared times the height. Oh, not times, sorry, that's 1. 2 pi r squared. And then we would add the lateral area, which again is 2 pi r h, which is the area of that middle ring. Volume is the area of the circle times the height. So we write it as pi r squared h, because the area of a circle is pi r squared. And then we multiply it by the height. Okay, the cone, the surface area is the area of the base, which is pi r squared, plus the lateral area, which is pi r L. And again, L is that slant height, which is here. Okay. And then again, my height is here. My volume is 1/3 pi r squared h. Okay, one thing to know, sometimes you're asked of why it's 1/3. So if you take a cone, or sorry, a cylinder, and then you draw a cone inside of it, what you can see, and this, I'm not the best at drawing, so bear with me. This cone here is a third of the entire region. Okay, so if you put a cone inside of it, it's going to divide it into three parts: the cone, this region here, and this region here, and they're all equal parts. And so the cone's volume is a third of the cylinder. Okay, and then we have a sphere. So this is my sphere. All we need to know for a sphere is a radius. And the surface area of a sphere is 4 pi r squared. And the volume is 4/3 pi r cubed. Okay. And a sphere is just a ball. That's what I mean. So those are all the formulas for surface area and volume. And then in class, we will do practice with this.